Okay, so this would be like, yeah, like like a simple example, right? Then I could go and has everybody worked with matplotlib, for example?
Yeah.
Yeah. Okay. So I could go and I could create. Let's see. I could go and create something similar. Instead of just 10, I'll create it like this. And then let's see. X. And then we're going to plot it. This is going to be a little bit different from the first example in the sense that sometimes it's easier to see what it is that we are doing. So let's see. For PLT. Okay. So here what I'm doing is I'm just creating more or less exactly the same thing as up there. Instead of 10 numbers, I'm just creating 20, and then I'm creating an X and a Y, and I'm plotting it through matplotlib. And then we forgot to insert our magic line in here, very useful.
Can you increase the size a little bit?
Yes. And then like that? Okay. So yeah, one of the nice things about matplotlib that I'm pretty sure if we ever ask Stack Overflow, what's the one line that everybody looks for? It's the inline over there. Because usually when you're plotting with matplotlib, you're only going to get this thing here, right? And for us, that's not going to mean much, right? So a lot of times, if we don't put this, we just get the matplotlib message that we get here, right? So then here, not doing anything fancy, right? I'm just saying it, plot whatever it is that I have there, right? And the plot would say, I would say it's one of like the very basic ones, right? And I would say it's fairly good because we can just throw pretty much anything at it, right? And it'll figure it out, right? And then, yeah, like we just generated our values and whatnot, and then we got a nice graph down here. Were you all able to get this? Yeah. If I'm going too fast, let me know. Okay, so let's see. Now, I'm gonna go and I'm gonna use one of the other big libraries that we use with Python, right? Have you ever heard of SciPy? So in here, I can say, I'm just going to create this. I'm going to say data is 1, 3, 4, 4, 7. Like I said, like I don't want to create a big thing here, right? I'm just going to keep it simple, right? So we can just kind of understand it, right? And then when we need to put like 5 million in there, we know it's doing whatever it is that we want it to do, right? Yeah. So then here we go and the stats.mode. I can get the mode of this and I can go data. Boom. Okay. So what am I doing here, right? SciPy, I would say it's one of like the big libraries in Python, right? Where you're gonna have all of these different functions for calculating pretty much anything you want to do with statistics with your data, right? Anything you need to do with statistics, I would first go here, right? And you'll find it here, right? If it's not here, it's because it's probably something that needs a little bit of tweaking or whatnot, right? But I would start here. Like in the first, as in the first example that I did here with the NumPy, right? NumPy also has the different functions, right? But I'm pretty sure that if I go and instead of mode, right, I go and I get the mean of my data, probably. Oh, let's see, I would probably, look for it, right? But like it should be there, right? SciPy is going to be one of those big ones, right? And with the stats, well, I just called it stats, right? But it's going to be like if you use a NumPy, for example, it's called NP, like Pandas has its own like standard abbreviation, right? You can call it whatever you want. But like just for reading purposes, it's kind of easier to like keep it like this, right? If you want to go in and do something a little bit more involved, for example, okay? So let's say I'm gonna create X, and I'm gonna use NumPy here, and I'm just gonna create random numbers. And then let's say, as I was saying before, with this plot is pretty nice in the sense that I do not need to work with it that much. And then I can just go there here and boom, I have my data. Like I have a visualization of my data, okay? So here's what I did, right? I just created 500 points at random, right? And I just threw it there and plot pretty much figured out that it was a scatter plot, right? Like I do not need, I just throw it at plot and then off it goes, right? Obviously there are a lot more, like there are other libraries within Python, right? Same thing as in R, that will give you like other things that you want with your plots, right? Like yeah, I can add a legend here. I can add titles and all this and that, right? But maybe we're just playing around with our data, right? And we just want to see it, right? There are other things that I can change here. Like let's say here I said I wanted periods, right? I could say I wanted a plus sign for my data, right? And then it changes, right? So it's pretty easy to use, right?
Sorry, what is the y-axis in this case?
Excuse me?
What's the y-axis?
Oh, I just created 500 random points.
Oh, okay.
Yeah, it's all at random.
Okay.
Yeah, like I could have had
But it's not just the x and y value for
no. So it's just through like the 500 points, right, between 3 and -3 there. Yeah, I was just trying to see like how to show like another way of showing your data, right? Because a lot of times we'll see like different things, like we'll see something like this, right? And then we go like, okay, what's happening here, right? But then I see that just visualizing your data or your results help a lot, right? And okay, so let's see.
Can I ask a quick
Sure.
follow-up question about generating random numbers? Can you do, specify distributions using these libraries? Like, for example, if you want to randomly sample from a log normal distribution defined by a geometric mean and a geometric standard deviation, or?
Yes, you can. Yes, I would look more into like let's say here, for example, I'm using a NumPy, right? So if you go in and look at the documentation for NumPy, right, and look for how to do the random like numbers or whatever, right, you could find something there, right? I'm pretty sure there should be something there. Like I haven't. Yeah, yeah. You could probably like I said, right? Try NumPy, try SciPy, right, and you should find something there, right? It should be there. right? So yeah, right now, everything that we were doing was just like throwing it to plot, right? To the plot function here, right? But then I could also call this. I could just call the hist function, right? And I could say the hist is going to throw me a histogram, okay? And then I can grab all my points that I randomly generated in X, and I want it to be put in 25 bits, right, throughout the entire thing over here. And then I just go like this. And this is one of the things about matplotlib that I need to tell it show, right? And here you go. Here's our histogram of the data that was generated, right? So yeah, a couple of things here when using matplotlib for the first time, right? I always need to tell it to show, right? And then the other one was remember this line over here. If you don't remember this, trust me, you'll go in the Stack Overflow and look for it, because otherwise you're just gonna get this, something like this, right? Yes.
Sorry, can you explain the show, because you didn't need to use it here, and I didn't need to use it in my, like I can still see it if I don't put the show.
Oh, you had the inline and
like you were able to show that plot without typing in.
oh, okay, here. It's coming up, but it's coming up with this.
Right.
Okay.
But and your plot a little bit, right?
Then it doesn't show. Oh.
Okay.
So I guess
It's just to remove that line.
Yeah.
Okay.
so if you do the show, then it doesn't show that
So
information.
let me see here. Okay, it's showing because of the line that I threw in here. But if I threw this out, for example, let me see if it still shows. Well, yeah, I would have to reset the kernel here. I'll just leave it like that for now. But yeah, like usually the proper way to write it, it would always be put the show.
Especially if you're annotating a lot of stuff.
Yes.
On the graph. So you'll say a line for the type of plot and then a line annotating some type of statistics on the plot, and then so you have a lot of lines, and then you would have to do plot show so that you can see that final
Yeah.
with all of these things.
Like in this one, for example, it's just 2 lines, right? But like, let's say here, right, I could probably tell it that I want an X label, a Y label, a label for the whole graph. I want a legend. I want the lines. I want to change the color, and I want this and that. And then all of a sudden, it turns into something like this, right? Yeah, so it's a little bit more involved sometimes, but like, yeah, it's just one way to do it. Then it's a little bit different from like, let's say ggplot, that you just put everything on one line, right? Yeah. Okay, so then let's see. Yeah, I think we already did this one, right? Like, yeah, going back to the plot part, right? I just did plot and histogram, right? But if you look for it, right, you'll have a lot more examples out there, right? And it will definitely help you to throw out your, yeah, like here, right? It's just a little bit different, right? But like you have different ways of showing your data, right? Which is something that does help me, for example, with what I do day to day, to kind of more or less understand what it is that I'm working with, right? And then we'll see a couple more examples along the way. Okay, so as for getting information about the data that we have at hand, okay, we can do other things like like let's say we want to be a little bit more descriptive about what it is that we're going to have here, right? Like we're not just going to show a picture, right? We can, if we're writing a paper, for example, right? I can go and this is like to give you an example, right? I want to go and I want to say the minimum value of X, for example. That would be it. If I want to go and I want to do the max. Like I'm not doing anything in particular per se. It's just to show the, like, you can just go and start building on it, right? I can show the maximum value. I can show like the mean again. Okay, and I want to show like the variance. Okay, and then boom, here I go. Okay. So yeah, this would be one way to start populating my data, right? I could do it like this on print statements. I could save them into variables and then use these variables later on for any calculation we want to do, right? So it's just like different ways of obtaining my data, right? So this is if I'm doing everything by hand, right? As we will see, oh, I have another example here. Let's see. So let's see. Okay. So remember we were using a SciPy and we called SciPy as stats, right? I can just say stats dot describe, and I can do here, and boom, it gives me this, right? So it more or less throws everything at me all at once, right? So that's one of the nice things about using these libraries, right? That a lot of times all this heavy lifting or heavy work has already been done for us, right? We just need to go in and read a little bit about the documentation, how to find all these things that we want to do, right? I'm pretty sure that any calculation or anything you want to do, somebody already wrote something for it, right? And it would be the same thing like in R, for example. Like there's going to be a lot of things that you're already going to find over there. And then like here I'm throwing everything at screen, right? But like let's say you wanted to grab it to use it for something else later, right? You could do something like I'm going to store the noobs here, right? I can say S min, S max, here, okay. And then if I did this, right, I can do, and then I only have one value that I wanted, right, instead of just getting the whole thing, right? And I can just print this statement again, but this is just more or less to show you like how you can get like individual values. If you're throwing like a lot of different values from one function, right? You can just start naming it like that, and then it'll fall into place and just use it like that, right? So that would be the same thing as this, right? Like if all of a sudden you go like, okay, but how do I get this? Right? You just do it that way, and it's going to be a lot easier, right? So then, let's see. You want let's do something a little bit more involved, probably. And then, okay. So let's say from scipy.stats input norm.
Can you scroll up just a little bit on the screen?
Oh, sure. Sorry. Yeah. Normal equals RES. So we're gonna go and create a size of 1,000. Oh. size of 1,000 and log equals 0 and scale equals 1. Okay. And then, oh, forgot to import this one. Okay. And then we're using matplotlib before, and now we're going to use something called Seaborn, which is just another library to do other type of plotting, right? And now we're going to see a little bit of the difference of why I'm using another library, right? So then, let's say I'm going to use this plot. If you load the libraries first, you can just hit tab on your keyboard, right? And you start writing the functions, right? They will come up, right? So that's a little bit easier for you if you're familiar with the libraries, right? Or just you'll get a little bit of help with this. And then let's say I want the data normal. I want the bins equals 100. True. Sky blue. And then the other nice thing about using these libraries, like in this case, Seaborn, right? You'll see that you have a lot more colors and a lot of other things that you can edit, and that will obviously make your life easier. Like, let's say you're writing a paper, right? And you want to create something like very nice, right? And then, okay, let's see. Let me finish this one. So, equals, let's say, line width. So here, this one's taking a little bit longer, right? Because I am saying a little bit more of what it is that I want, right? Like, let's say here, I'm calling an alpha, right? I'm specifying the line width that I want to throw at it, right? And then, this plot. Oh, can't type today. No. Yeah, this is usually what happens when you rectangle line width. Oh. When you're typing, when you're trying to code on the live, usually this happens. Okay, so yes, it took a little bit more, but like here I'm using a Seaborn, right? I'm creating my normal distribution data, right? And I'm saying like the type of color that I want. Like let's say I want a light green. Let's see if green exists here. There you go. And I can change it to anything, right? I have here this line over here, which is my KDE that I wanted, and I'm saying it over here. I can change it to false if I don't want that line. I can change my alpha to 0.6, for example. Let's see. So it makes it a little bit lighter, the color, right? So obviously, one's going to be very dark, and I can bring it down to like, and this is, for example, if I'm going to start to throw one thing on top of another, right? Like, let's say I have different values that I want to show in the graph, right? So yeah, this would be one of the things that I can get off from Seaborn that I might not get from a Matplotlib, like right off the bat, like that.
So the Seaborn tend to have more flexibility for plotting than Matplotlib?
I would say you need to acquire a taste for it. That's the way to put it.
Okay.
Because yeah, so I mean, like, there's so many libraries that you can use within Python, right? You can use a Seaborn, you can use a Bokeh, you can use like they even have a version of ggplot, for example, for Python, right? So like if you're very used to ggplot, then you use that one, right? But then a lot of these libraries, what they do is that they function on top of matplotlib.
Okay.
Yes.
So I was wondering because it displayed matplotlib right above it.
Yeah. So a lot of these, yeah, they use like they have matplotlib in the bottom, right, and they
Okay.
just draw on the top.
Okay.
Yeah. So then, so this is like just doing my normal distribution, right? And like, let's say if I want to do something a little bit fancier, right? I can go and let's see from SciPy, like here, right? Obviously, I need to go and import the, like first we just started with stats, right? We're just doing statistical, we're just trying to get like information from our data, right? Based on like the type of distribution that we're doing, like we might need to import other things, right? And the reason why we do this is that like if you try to import everything at once, right, it's going to take a little bit longer, right? And maybe you don't need everything to like in what you're doing, right? So here I just imported the library for normal distributions, right? And here, for example, I'm going to import another one, right? And I can go here and pass on. So let's see. I'm going to create a similar data set here, right? Okay. And I'm just going to say pass on. I think in the you shared the notebook, right? Okay, yeah, and in the notebook, all of these are there, right? So you can find like a lot of examples there, right? And then let's say SNS dot, I'm just going to do a distribution plot here. Okay. I'm going to do my data. Okay. I can do, let's see, let's do 30. 80 false. And let's just copy the same thing from up here. Okay, so here you go, and you see like it changed a little bit, right? Because here I said I wanted a color, right? Here I did not say a color, but then everything's going to come out blue, right? I said my KDE, I want it false, right? I can say I want it true, and then I'm going to get an approximation there of what it thinks it should be, right? Right. I can have it there. If I don't want to, I can just take it out. I can go and like here, I can say this, and I can just assign everything to one variable, right? And then I can say set, and then I can say label equals okay. And then a y label equals frequency. And let's see what happens now. Oh, yes. Okay. And there you see we have our X and Y labels, right? So it's just going to be like if you like I said, you get the acquired taste. For you to get used to Matplotlib, I would say it takes a lot of time and a lot of effort, right? Because a lot of times just to put like you can do like a lot of like really nice things with Matplotlib, but like let's say you just want to put a arrow here pointing to this a bar or whatever, right? It'll take you a lot of time just to like figure it out. but you can do it. You can do it, right? But like, just try to see if you can choose one library and just stick with that one, right? Like, I find that another nice one would be a bouquet, right? I'm using it, like, let's say at work, I use one called a Dash. I don't know if you've ever heard of it. But I mean, it all depends on what you use it for, right? Like, let's say with Plotly. Plotly, right? So for Plotly, I can do something like have you ever done visualizations in Shiny? Okay, so
Interactive.
yes, yeah. So then in Python, you can do something. That's what I use Plotly for, right? You create something called a Plotly dash. So you create dashboards, right? And it would be more or less the equivalent of doing something in Shiny, right? So I mean, like, yeah, some people won't be that versed like in Python and R, right? So they won't be jumping between both of them. So you need to find like the equivalent, yeah. So yeah, so let's see. Okay, so this is more or less just playing around with make-believe data, right? So then this comes to the point like, okay, what if I want to work with real data? Do we have time for it? Or yeah, okay. So then with a lot of this, right, if you see, we're just make-believe or whatnot, right? But then another library that I would say is very important, or at least for me, for statistics, right, is Pandas. I don't know if you ever heard of it, right? Pandas, okay. So let's see. And so I know, so yeah, somebody came about and created the name. Don't ask me why it's called Pandas. Yeah. Okay. So I am just going to go ahead, right? And I'm going to call my data, run data, right? PD read. And like I said before, right, just hit tab. And then like you'll have different things. Like I can, like, obviously I'm importing the CSV, right? But you can do a lot of stuff with Pandas, right? Now I would say it's very useful, right? So I'm going to import, I think it's called a marathon results 20. This is a data set. Oh, sorry 2015. Okay, here. And the same thing, I just hit tab and then it comes up, right? Okay, so then when I'm gonna read my data, right, first I just go about like this, right? And I can read it, and I'll just do run data dot head, and I can see what comes up. Well, yeah, I'll ignore the warning for now, right? And then I'm like, more or less, okay, so what type of things do I look for? Okay, when I'm reading my data, I try to see that the column names are there, right? They're not a row, but they're like actually a column name, right? And then what would I change here? Okay, yeah. So then something that I don't like about the way it was read is that I would say the index call equals 0. Okay. And then let's see how this changes, right? So what's going to happen here, right, is that it's going to grab my first column here, and it's going to throw it as my index over there, right? It could be over here or whatever, right? I'm just going to throw it out there. Let's see if this fixes. Okay, it looks a little bit different, yeah. So yeah, I would say, yes, I can live with this, right? A couple of, this data set is I downloaded it from Kaggle. I don't know if you ever heard of it. So usually you can do like a lot of you can find a lot of people working on machine learning problems or whatnot over there, and you'll find a lot of interesting data sets. The only thing that I did change was that usually the times here that are shown, they're all shown in like hours, minutes, and seconds. So what I did with the time is I just translated everything into minutes, so that it's a little bit easier to work with, right? But if you download the notebook, you'll see how I did that, right? So yeah, so then I go in and I have all my data here, right? So then remember what we were doing over here, and let's see, which one was it? Oh, from was stats, that we were getting all the information, stats described. We're getting all this information from our data. Remember this one? Okay, with pandas, right, I can go ahead and I can do this. So all our data is in run data. I can say info first, okay? And then, okay, so this helps us. So I can get all the column names of all my data. Remember we read CSV at the beginning? Yep. Okay, so first of all, this is a lot, like usually the way that you will get your data from, right? Like nobody's going to be inputting all the, like a whole bunch of data in there, or creating like random data, right? So I'm just getting the info from my data here, right? I get all my column names. I can see how many, what's the, like how many items I have of each one. I can see what it is. Object is usually comes out as a string, okay? I can see if they all say non-null, but yeah, they're all going to be integer or whatnot, right? So this is more or less like a very rough information, like graph of what it is that I have, right? But I can also go and I can also say describe. And then boom, here I get more or less what I was getting with the stats, right? But here I'm just getting it with the pandas, right? So yeah, like I can say, okay, so let's see. Does anybody run here? No? No, okay. Yeah, so this is data from the Boston Marathon in 2015, right? So here I can see things like, let's say the youngest person in age was 18 years old, right? Yeah, because they don't want people less than 18 running a marathon for some in case something happens to them. But yeah, I can also see the oldest person was 82, right? Like just by looking at it like quickly, right? Yeah, so this would be like one way to look at it, right? I'll have like different, like a lot of other things that maybe you can just get your data from here if you want it. So let's see. Let's work a little bit of magic with this data, right? So I don't want to type that much, so I'm just going to say run data age. And I'm just going to throw it into the X value here, right? And then going back to our examples from before, I'm just going to say plot.histogram, or hist, right? I'm going to say X. I want plot X, and I want to say bins equals 25, and plot.show. Okay? And then here you go. For me, this was a little bit interesting when I started playing around with this data set and I was preparing this, right? Because you can say like, yeah, usually when I'm young, I want to run a marathon or whatnot, right? But like, yeah, a lot of people don't like doing that, right? But you can see that more or less when you're like 45 or so, that's when most of the people that ran like the Boston Marathon in 2015 were like that was their age, right? And yeah, you can see that like some people are like you remember like the highest value we had was 82, right? So it's this one over here, right? So yeah, like if you remember, right, all we did was a one-liner, right? And we can pretty much start getting an idea of what our data looks like, right? And like we can see if it has like some sort of a, like let's say if we're gonna look at our age, right? Yeah, we could probably throw it in normal distribution per se, right? And just start playing around with it, right? If that was what we wanted to do, right? we can also do something a little bit fancier, for example, and this would be one of the reasons why I would use Seaborn, for example, instead of matplotlib. So like, let's say, okay, so SNS dot count plot, and then I'm gonna say age. I'm gonna say data equals run data, because it's the run data that there's already something called here palette and cool warm. It's called cool warm, and I'll give it colors based on hue equals sex. We'll give it a color based on sex, right? And then let's see what comes up. Oh, here you go. So if you see, it looks a little bit better. I can actually say a couple of things here, right? I can say, let's see, G equals that figure that set. Oh, doesn't come up. Set size inches 13,8. And then it'll probably be a little bit bigger. Okay, there you go. So yeah, like you can just add the, let's say you want a bigger, oh, okay, look at this, for example. With the one-liner over here, I was able to create this plot down here. And then I did not even have to put the titles on the X or the Y axis, right? I did not have to create a legend. All of this was done automatically by Seaborn, right? So this is one of the things like Matplotlib will not do for you, right? You have to do everything, like it'll put it for you there, right? But like you need to manually go in, okay, how do I add this? How do I add that, right? And like here, I could do with a one-liner. I could just go g.set, and I'm doing g because I assigned like the plot to g here, right? I can just say g is set title, and then I can say participants. Oh, okay. And then yeah, whatever you want to put there, right? And title, yeah. Okay, there you go. So yeah, like obviously I did not want to type like a very involved title there, right? But you get the idea, right? So yeah, so this would be like one of the reasons why I started using Seaborn, right, instead of just using plot, right? Because plot is going to be like a line for the x-axis, a line for the y-axis, a line for the title, a line for the color, a line for this, for that, and then it starts getting very big, right? Here with the one-liner, right? I just say I create my legend here, right? And I start doing like I separate the data by colors, right? Which is the hue that they call it here, right? There's this palette, right? I just picked one out, right? I'm pretty sure that if you go in the documentation and you like flowers or something, there'll probably be something flowers or something with Star Wars or whatever. Yeah, I'm pretty sure they're going to have something there, right? Okay. Am I going too fast or we're okay? Yeah? Yeah? Okay. Let's see. Oh, okay. Let's see. We can do something like X, comma, shade equals true. Okay, so here in everybody know what the kernel density estimation plot is, or has more or less like an idea? Like it'll grab like a small portion of my data, right, and I'll do like an estimate of what it thinks it is, right? So like here, what I'm using is I'm using, like I can say shade equals false, right? And it'll just give me a line here, right? So like it gives me a lot of things, right? Like I can change the color instead of R, which it means red, right? I can say, let's see what this gives us, orange. Oh, orange. Okay, yeah, there, green, right? So yeah, like I would have to look for the like a chart with the colors, right? Then I can say this is false, for example. And then you see here, it didn't give us the shading, right? There are going to be others, like on the notebook, you're going to see others that are a little bit more involved, right? But like you can pretty much find a lot of different examples for what it is that you need, right? How much time do we have left?
5 minutes.
Okay, sure. Oh, here's another one. So now that since we already have our data in X, right? I can go and box plot, okay? And then I can just go here and sim equals star. Okay, so I go here and I don't know if you remember from up here, we're trying not to type that much. So what we threw in X was just the age of the run data that we had, right? So we're just playing around with the age of the runners that were in the Boston Marathon in 2015, right? Yes. Okay, so like let's say here, right, I can see that I can see like, yeah, pretty much everybody's gonna be like between 30 and 50 years old, right? Like, yeah, like what we saw, right? Most of the people like are gonna be like around 45-ish or so, right? We're gonna have a couple of brave souls up here, right? But not many, right? But yeah, so like I said, right? If we go and we start visualizing our data, right, it'll help us like guide us in different directions of where we can take our ideas, right, and try different things, right? Right? Make sense? Yeah. Okay. Let's see. Oh, so let's try this one. Scatterplot. X equals times means y equals age data equals run data, and then q equals m dash f. And let's see what happens here. Okay, so it took a little bit because I was thinking. So here, what I'm trying to do is I'm trying to compare the time in minutes of the entire race that it took them to finish the race, and I compared it to the sex of the runner, right? And if anybody here has ran before, it's not really related that much, right? Because there's a lot of other factors that need to be taken into consideration when running a marathon, like how much you trained and like all these other things, right? So yeah, we can see that usually like the slowest people in the group, right, were well, the slowest and the oldest ones were a male, right? There's one lady over here that's probably 82 as well, right? Kudos to her, right? But yeah, like the slowest runners were two males over here. Hopefully, nobody was left behind, right? But yeah, like we can do like if you saw here, right, a one-liner, right?
What is the size of are there different sizes there that I'm looking at here? Or different sizes of the dots?
Oh, they're all the same size. The thing is that when everything is more or less joined over here in the middle, like there's so much data there that it's just like yeah. But like I'm not actually looking at the white spot here. Right? I'm actually looking at like what's around it, right? So I can see like most of the fastest runners, right, were male, right? The fastest runners, right? But then like more or less the majority of the oldest runners were also male, right? Yeah, there were a couple of females over here, right? And within the slow runners, yeah, there were a couple of females, right? But then most, like what I can say from here, I said that most of the female girls that went into the race, they meant business, right? So they wanted to get there fast, right? So yeah, everybody that runs a marathon, right, like probably wants to do a good time, right? Not like end up as the last people in the race, right? Yeah. So yeah, that's the idea, right? Like yeah, I can if I wanted to go in and I wanted to get more information, like over here, right? I would probably take out a sample from over here, right? And I would start looking in there, what's going on, right? But like yeah, like I said, a lot of other things could like be taken into consideration, like what type of shoes you were wearing, like did you train a lot, what did you eat, like what's your weight, what's your height, and a lot of other things that would vary, right? Let's see. I have so. Oh, okay. So, like, let's say I want to see this, for example, stats, which is going to back to SciPy. I want to see find repeats, and I'm going to run data, and I want to see pace minutes, which is the pace in minutes. And then I can see like what kind of paces were repeated, right? And this is just to show like I can still, even though I'm still using pandas, right? I can still use my statistical functions from before, right? Before I started calling my data sets in the CSV, right? I'll find like just go in and try to see what it is that that you need. And most likely, like I said, there will be a function for it, right? So it's not like I need to create a module to start counting all the paces, right? And try to see which ones are repeated or whatnot, right? I just went there, took a couple of minutes, read the documentation, found what I needed, boom, it's there, right? So yeah, a lot of it's already going to be there for you. So yeah. Like I know that you're probably going to have a couple of other nice examples in the notebook that it's out there, right? And hopefully you enjoy them, right? And yeah, I would say yeah.
Thank you. Thank you.
But yeah, you